In this video, I'm going to cover section 9.2, Measuring Area in Contemporary Mathematics from OpenStax. So, the following are the learning objectives for section 9.2. We want to be able to identify reasonable values for area applications, convert units of measures of area, and solve application problems involving area. So let's go ahead and look at area. So area is the size of a surface. Determining the area of a surface is important to many everyday activities. For example, when purchasing paint, you'll need to know how many square units of surface area need to be painted to determine how much paint to buy. Square units indicate that two measures in the same unit have been multiplied together. For example, to find the area of a rectangle, we multiply length units and the width units to determine the area in square units. So for example, 1 centimeter times 1 centimeter is 1 centimeter squared. The formula used to determine area depends on the shape of that surface. And here we will limit our discussion to the area of rectangular shaped objects. Given this limitation, the basic formula for area is length times width, or A equals L times W. So units, let's look at those. So this is square kilometers, or kilometers squared, to meters squared, or square meters. So since 1 kilometer is 1,000 meters, then 1 square meter would be 1,000 meters, 1 square kilometer would be 1,000 meters times 1,000 meters. So we're looking at 1,000,000 meters squared is a kilometer. So I want to write that right here, and let's get a different color. So what this is saying is 1 square kilometer is equal to 1,000,000 square meters. So it makes a huge difference in this case which unit we're in, right? And so that's the conversion rate. Or what about meters squared to centimeters squared? Well, meters times meters is meters squared. 1 meter is 100 centimeters, right? So remember that. Keep her dancing because dancing creates marriages. So we're here at meters. So if we go over to centi, that's 100. But if we want a square meter, then that's 100 centimeters times 100 centimeters. So that's 1,000 square centimeters. So that is what we're saying right here, is that a square meter is 10,000 centimeters squared. And then you can see here, centimeters to meters, that isn't as big of a jump. That's only one jump from C to M. So that would be 10, but that's still 10 squared. So 1 square centimeter is 100 square millimeters. I'm having trouble with my zeros today. All right, so let's look at the next. Let's look at which unit of measure is most reasonable to describe the area of a sheet of paper. Would that be kilometers squared, centimeters squared, or millimeters squared? Well, typical sheets of paper, right? Typical sheets of paper, if I was to draw a typical sheet of paper, I think we typically call this an A4 piece of paper. This would be 11 inches, and this would be 8.5 inches, right? That's our normal sheet of paper, is 8.5 by 11 inch sheet of paper. Well, kilometer is kind of on the same magnitude of a mile, right? So 1 mile, just to give you an idea, is about 1.6 kilometers. So kilometers squared is definitely going to be out. That's way too large of a magnitude. We're not measuring paper in miles. We wouldn't want to measure it in kilometers. Now centimeters, that is on the same kind of playing field as an inch. Because if you think about a ruler, it has an inch side and a centimeter side. So they're kind of measured the same in comparison. And then millimeters, that is 1/10 of the size of a centimeter. So that might be a little too small. So again, because we're usually measuring inches and the metric system centimeters are used for measured usually things expressed in inches, then it would make more sense that we would want to go with centimeters squared. So again, a kilometer is just way too large. A millimeter is just kind of too small. So a centimeter squared would be kind of that Goldilocks just right amount when measuring paper. And if you went and looked at a ream of paper, you'll probably see that it's measured in 8.5 inches by 11 inches, and it'll probably tell you also centimeter conversions as well. So how do we convert between, again, those different, this time we're talking about area, so these square units? Well, we have to remember that our conversion factors are squared this time. So let's move on and just look at an example. So a plot of land has an area of 237,500,000 square meters, or meters squared. So what is the area in square kilometers? Which we would definitely not want to, write it in square meters. That number is pretty large. So square kilometers would make more sense. Plus, it's more comparable to the U.S. system of miles. So again, there's kind of two ways you could do this. I really like, again, this table. So if we do 237,500,000, and that's square meters. And so we're wanting to go from square meters to square kilometers. So how many square meters are in a kilometer? Well, we just talked about it. It is 1,000,000. But I want to give you a visual representation of that. So let's go over here. Let's draw a square. All right, so pretend with me that all of these sides are the same length, and that it's 1 kilometer by 1 kilometer, right? So it's a square, and that's a kilometer. So remember, 1 kilometer is 1,000 meters. So that's 1,000 meters. And so if we multiply 1 times 1, that's 1, and then a kilometer times a kilometer is squared. And then 1,000 times 1,000 is 1,000,000, and that's meters squared. So that's where that idea comes from, is because area is length times width, and in this case of a square, they're the same. So 1 kilometer times 1 kilometer is a square kilometer. 1,000 meters times 1,000 meters is 1,000,000 meters squared. And so that's where we get this unit conversion. And so remember, if it's on the bottom, we're dividing. If it's on the top, we're multiplying. And since we've got the same units here, they cancel each other. So I'll come down here. And again, we get this nice little million divided by this amount. 1, 2, 3, 4, 5, 6. So we should be looking at 237.5 square kilometers. Now, what was my little shortcut there without actually getting the calculator out? Well, here we have 6 zeros, so that means I'm going to move 6 decimals. 1, 2, 3, 4, 5, and it's going to land right there for 6. So that's how we get 237.5 square kilometers. So, that's a pretty good plot of land, because again, 1.6 kilometers is a mile, so, pretty good bit of land. But that's our final answer. So, what about the other way around? So here we've got a plot of land that has an area of 0.04046 kilometers squared, which is, kind of small. What is the area of land in square meters? So in the previous one, we had a lot of square meters. We had a large number, and we converted to kilometers squared, and it wasn't as large. Here we have a tiny value for square kilometers, which means that probably square meters would be better. So let's again set up our conversion kind of table. So 0.04046 kilometers squared. And we're trying to get rid of kilometers squared, so we'll put that in the bottom. And we're trying to go to meters squared. And again, 1 kilometer squared is 1,000,000 meters squared. And now we're going to cancel the kilometers squared because it's on top and bottom, and that's what we want to do. And then we're going to multiply by 1,000,000. So using that trick, we got 6 zeros, we'll move 6 places. So 1, 2, 3, 4, 5, 6. So the result of this should be 4,046, and we're talking about meters squared. So instead of having that incredibly small, what I think of as rather incredibly small decimal, we have something more on the lines of, 4,046 square meters, which may seem a little more kind of usable, I guess I should say. All right. Now, a computer chip measures 10 millimeters by 15 millimeters. So this is pretty small. Remember, a millimeter is 1,000th of a meter, and it's 10 times smaller than a centimeter, right? So these are very small. How many square centimeters is the computer chip? So again, several ways you could do this. Let's start by, I'm going to first erase that little blemish. So let's start by drawing a picture. So we've got 10 by 15, right? Because let's say this is our 10 millimeter and this is our 15 millimeter side. So if we start by converting millimeters to centimeters, that will actually make our life easier in the end. So to go from 10 millimeters to centimeters, this is 1.0 centimeters. Because there's 10 millimeters in a centimeter, we just move 1 decimal place to the left. And here we're going to do, that's 1.5 centimeters, because again, we're just moving 1 decimal place to the left. So if we multiply these two together, 1 centimeter by 1.5 centimeters, then what we end up getting is just 1.5 centimeters squared. And that was really it. That's all we had to do in this case. Doing the table actually is more complicated than just drawing this picture. So I would advise you just worry about, looking at this picture and visualizing it. What would you do? But if you wanted to see the table, just because, maybe you like that, then what we would do first is we would find the area in millimeters. So the area is going to be 10 millimeters by 15 millimeters. So you're talking about 150 millimeters. And so we've got 150 millimeters. And we want to end in centimeters, and we want to get rid of the millimeters. So 1 centimeter has 100 millimeters. And so we're going to cancel the millimeters, and if we do this division, we're dividing by 100, so that's 2 to the left. So that ends up giving us 1.5 centimeters. And that would be the same thing we got from this little picture. So either way you want to kind of visualize it, that's my favorite, is the visualization, or just do the straight up calculation. They both come out working the same. All right, so what about some complex surfaces? On a side of a commercial building is a 12 meter long by a side of a commercial building is 12 meters long by 9 meters high. And there's a rolling door on this side of the building that's 4 meters wide and 3 meters high. You want to refinish the side of the building, but not the door, with aluminum siding. How many square meters of aluminum siding are required to cover this side of the building? So again, I'm a visual person. I like to try to draw pictures. So we've got this kind of 12-meter long side, and on this side we've got this, so let's label here. So this is 12 meters, this is 9 meters, and then on this side we've got this sliding door that is 4 meters wide and 3 meters tall. So how many square meters are we going to need? Well, we're only going to be painting inside here, right? Oops. So we're only going to be painting on the inside of, I can get my highlighter and kind of highlight where we're painting. Right, so it's just going to be inside here. Oop. Still getting used to using this right. So just that area, we're not going to be covering the door. So first let's find the area of the side. So the area of the side is going to be 12 meters by 9 meters. So if we do 12 times 9, that's going to give us 108 square meters. And so then the area of the door is going to be 4 meters by 3 meters. So that is 12 square meters. And then we want to do the difference. So we want to take out, we want to subtract the area of the door from the area of the side. And so if we do 108 minus 12, what we're looking for is, or what we're looking at rather, is 96 square meters of siding that we're going to need in order to cover the building. So 96 square meters would be our answer. So here's another kind of area of a complex surface. Because we've got this, weird rectangle. It's actually kind of two rectangles that overlap. So there's two ways we could solve this. One, we could slice it down vertically here. We're going to have to slice it. We're going to have to cut it into two rectangles. Or we could have cut it here. It doesn't matter. We'll get the same area. It just now depends which way. So let's do it this way. Let's cut it this way. So we're finding first the area of this little rectangle here, right? So this rectangle here, and that's going to be 4 centimeters by 1 centimeter. So 4 centimeters by 1 centimeter. So this rectangle is going to be 4 square centimeters. And now the next rectangle, let me change colors of my pen here, is going to be inside here. Now this long side is 7, but we cut out a centimeter from it. So this particular side here is going to only be 6 centimeters in length. All right, So this side is 6 centimeters in length. So the question then also is, how wide is this rectangle? Well, the full base is 4, and we cut out 3, so that means it's going to be just 1 centimeter here. You can kind of see that's to scale, but I wouldn't trust that always. So we can do 6 times 1, and so this rectangle is going to be 6 square centimeters. And so if we add those two together, we have 6 centimeters squared plus 4 centimeters squared is 10 centimeters squared. And there's another example like that in the book and in your online homework for this class. So I would say reference this video and look at how we've sliced this to try and solve it. Just remember that when you do that slicing that you are taking out some of the distance from other pieces. So if we would have sliced it vertically here, then we would have needed to remove 3 centimeters from this 4 centimeters to kind of get the same idea that this is 1 centimeter wide. Alright, so that is kind of the end of this video for section 9.2 measuring area. So if you haven't read the section, please go read it and do the your turn problems in the section. The answer to those are at the end of the section for you to review. And then go online and complete the associated homework assignments for this section to make sure that you understand the material and are being successful.